Good afternoon. We're given the problem, use the Laplace transformation to solve the given integral equation, where the equation is set as f of t is equal to cosine of t plus the integral from t to 0 of e to the negative tau times f parentheses t minus tau parentheses of d tau. So what we're going to do is apply the Laplace transformation, and from the left side, the Laplace transformation of f of t is just the Laplace transformation of f of t, and we know that the Laplace transformation of cosine of t is just 1 over s squared plus 1, and we know that the integral is actually the convolution of the product of those two um I wouldn't say components, but I guess let's just call it like that, where it's the Laplace transformation of um e to the negative tau times f of t, and what we know is that this is basically the same thing as the Laplace transformation of e to the negative uh, t times the Laplace transformation of f of t. And we know that the Laplace transformation of e to the negative t is just 1 over s plus 1. And we know the Laplace transformation of f of t is, well, it's the same thing, Laplace transformation of f of t. As we plug it in here, what we're going to get is this plus the Laplace transformation of f of t times s plus 1. And let me duplicate this. And now we're back here, guys. So the next thing I want to do is what you call it? I want the Laplace transformation of f of t to be on one side. So what I'm going to do is subtract um, f of t divided by s plus 1 to both sides. Well, subtract to both sides. And what I'm going to do is factor out Laplace transformation of f of t, and what I'm going to get is 1 minus 1 over s plus 1 is equal to whatever we left to the right side. And here, as I mentioned to the previous problem that we did, I want the 1 minus 1 over s plus 1 into one fraction. So I'm going to try to get common denominators, and the 1 will cancel out. And I'm going to be left with s over s plus 1 times the Laplace transformation of f of t is equal to s squared plus 1. Oh, I'm sorry. The Laplace transformation of cosine is actually s. So it's basically the same thing as everything we did, but it's actually an s. I'm sorry about that, guys. So what we're going to do is move this to the other side, and in order to do that, we have to divide it by both sides. Using the method of key change flip, what we're going to get is this. And then we can rewrite this as s plus 1 as s squared plus 1 is equal to the Laplace transformation of f of t. Here we do not have to do partial fraction decomposition. We could just rewrite it as s over s squared plus 1 plus 1 over s squared plus 1 is equal to the Laplace transformation of f of t. And now I want to take the inverse. the inverse of f of the Laplace transformation of f of t, which would be f of t is equal to the Laplace inverse of s squared plus s over s squared plus 1 plus the inverse of the Laplace transformation of 1 over s squared plus 1. From our table, we know that this is just cosine of t plus, and this is the, from the table, is just s of t. And we have our answer, where f of t is equal to cosine of t plus sine of t. Thank you for watching and have a great day.